Hello and welcome everyone to this virtual demonstration of GRACE-based smart irrigation tool. This tool has been built to improve the current practices of irrigation. Specifically, we have integrated gravity recovery and climate experiment or GRACE data with other satellites such as Landsat to produce irrigation advisory for targeted regions that are in greater need of this service. So let's see at a deeper level on how we can use this system and use its different components. Right, so on your screen, you are seeing this portal available at this publicly available website. I will first walk you through different components of the system so that you are aware of how to use them. On the left-hand side, there is a Layers tab from where the layers can be turned on and off as per the user needs. There is a legend panel on the right-hand side of the screen. On the top is for land cover, and on the bottom is for GRACE terrestrial water storage or TWS anomaly trend. The values can be read off from this color bar in centimeters per year of equivalent water thickness. On the bottom part of the screen, you are seeing a time series, which is the GRACE TWS anomaly time series over a selected period of time. The map is showing the GRACE TWS anomaly trend, as also mentioned by this label, over this particular time period. Now let's look at the different steps and how we can use them. So first step is to visualize GRACE TWS anomaly trend for selected dates. The user can change the dates over which the trend is calculated. So let's do that from this particular panel. I will change it to 2008 and press enter. So now we change the default time series time period from 2006 to 2008. The user can analyze the time series and check the different values from the small pullover dialog box. Also, the user can click on any point which is representative of a specific month for GRACE data, as I just did here, and the respective GRACE TWS anomaly map will show up on the map. The legends, they can also be read from the right-hand side of your screen, where the GRACE TWS anomaly is being shown in centimeters of equivalent water thickness. Again, the layers can be turned on and off as per the user needs. Now let's move on to step number 3, which is selecting a GRACE pixel for a pixel-specific GRACE TWS time series. So the idea here is to allow user to zoom into any specific region of interest and visualize the time series for GRACE in that region. So let's pick one of these points or pixels of GRACE data. As soon as I click on the pixel, the map zooms on to that particular region and shows up the two layers, but at a zoomed level to that region. You can also see a modified time series averaged over that particular region or the pixel of GRACE. Now let's move on to fourth step, which is to do the irrigation analysis. The user has been provided a number of options, and the user can select between dates, crop coefficient, buffer radius for calculating the ET or evapotranspiration. This will give the amount of water required and how much water is being currently used by the crops. This will also provide the user with an estimate of over-irrigation or under-irrigation that has been observed in the past. So user can change the default dates of analysis or these coefficients. And for the selected point, the analysis will be carried out over a buffer distance of the selected value here. I will keep the default values and run the analysis, which is the fifth step of this particular tool. As soon as I click run analysis, I see a point that is my selected point, and I see a message called computing, please wait. The analysis is being carried out on the fly on Google Earth Engine servers. The layers might take some time to load if the buffer distance is larger. As soon as the layers finish loading, which I can see from this layers tab, I can even log that tab to keep it on the map. I see multiple layers that have been loaded right now on the map. There are also modified legends for evapotranspiration and percent over or under irrigation. The different values can be read and in terms of the units and the values. Let's look at the different layers that are currently present on the map. So we have selected point, let's keep it on. We have over irrigation, or the blue points are actually showing that the regions are over irrigated and the red pixels are showing the regions have been under irrigated. Let's turn that off. So the next layer being shown here is the CBAL ET. CBAL is the method that is surface energy balance that gives us the amount of water required or used by the crops in actual. The values again can be read from this particular legend. Turn that off and we see a Penman evapotranspiration map calculated over this particular 10-kilometer buffer radius around the selected point. Again, the values can be read off from the legend. The user can also turn on the land cover, and as the user can see, the values have been masked out for the built region or urban region. All right, so there are also statistics of irrigation shown on the left side of the panel. Here, the water used that has been calculated from CBAL ET is 3.11 millimeters per day, averaged over this whole region and over the selected dates. We have water needed, which is the calculated from Penman-Montieth equation, is observed at 2.08 millimeters per day. And from these two variables, we have calculated here percentage over irrigation of 48.9% over during this time period and averaged over the entire region. The user can also change the land cover behind or the base map from map to satellite. If you want to go back to the GRACE TWS time series, the user can change the dates of the GRACE TWS analysis, press enter, and the map resets to the GRACE anomaly trend, as well as the time series of the GRACE. The user can zoom out and select another pixel of GRACE if the need arises and analyze the irrigation for that particular pixel. I hope this helps the user in using this particular tool. For any questions or concerns, please email me at the email address provided at this bottom of this tool. Thank you and have a good day.